Hello everyone, this is Catalin from the Coding Cave and welcome to the first episode of my data science learning series. Today we are going to learn about visualizing data with Matplotlib. For those who don't know, Matplotlib is a library, a Python library, which enables us to visualize data and seeing it as charts, graphs, and so on. So let's get started. Firstly, we are going to need to install Matplotlib. For this, we are going to use pip. So just open your command prompt and type pip install matplotlib. I already have Matplotlib installed, but for those of you who don't already have it installed, you are going to have to wait for a few moments and then you can continue. So, just open your Python IDE or any kind of IDE. For this lesson, I am going to use Atom, but feel free to use any kind of text editor or IDE as you want. And just make a new Python file. I mean, 3 Python files. So the first thing we are going to learn are the line charts. So just open your uh, Python file or make a new file called linechart.py and let's get started. So let's first import matplotlib. So just type from matplotlib import pyplot as plt. You don't really have to import pyplot as plt. You can use any name you like, but usually most of the people just use plt, so it's kind of a convention. Now let's come up with some data to represent. So I'm going to declare two lists here. Let's say data 1x and data 1y. So just come up with some random values like this. 5, 1, 3, 2, 15, 31, 6, 7, 2, 8, 1. Now let's make a plot. So just write the following: plt.plot data 1x data 1y. So basically what you do is that you specify the first list, which should be the list of x values, and then the second list, which should be the list of y values, and then you just type plt.show, compile, hope everything works, and here is the graph. Now, Matplotlib offers you several ways to customize a graph. Firstly, you can add a title. So let's just see here plt.title and let's call it line chart. Now, if I run it again, as you can see, the text line chart appears here. Now you can also name the X line and the Y line. So to do that, all you have to do is type plt.x-axis x label, sorry for that, and the name of the label, let's say the x values of our data. X label, sorry for that. Now if you run it, as you can see here, it says the X values of our data. You can also customize the Y axis in a similar way, and let's name it the Y value of our data. And now if we just run it, as you can see, here it says the Y values of our data. You can also add a legend, so plt.legend, and then you can specify a location. So you just type the argument loc, and you can use a number, for example number 9, which is the top center location. Yeah, as you can see, our legend doesn't say anything because we have to label our plot. So if we want our lines to be shown in the legend, we have to label them. So you just go to plt.plot here and come up with a label. Let's name it random value. And now if we run it, as you can see, we have a legend which says random values. We can also move the legend around. So for example, we can use the location 1 and our legend moves. We can use 5 and our legend moves. You can just come here and say location equal best, and it will find the Matplotlib will find the best location for your legend, so you don't have to worry about that. See? Now, let's try to plot a function. So, in data science and machine learning in general, there is a very popular function called the sigmoid function, which is mostly used for a thing called logistic regression. I am not going to go into too much detail because logistic regression will be presented in some episode in the future, but we are going to plot this function. So let's just define a function called the sigmoid function, which takes an x value as input. The formula for the sigmoid function is as follows. Let's import math here. So the formula for the sigmoid function is the following: return 1 over 1 plus basically the mathematical function would be e to the power of minus x, but you cannot just do that in Python. In Python, if you want to raise the number e, the Euler's number, to the power of x, you use the x function from the math library. So you just type math.x and minus x. And now we have the sigmoid function. We should also come up with some values for the sigmoid function. So we'll generate a list here. Let's say input values equal x for x in range minus 10, 10. And we should also come up with the output values. So we will create another list, output values equal sigmoid function of x for x in input values. Now we can plot this function. So plt.plot input values, which are the x values, the output values, which are the y values. We can also customize the color of our plot, so we can just type color equals red, and we can also come up with a marker. So let's say marker equals O. Uh, to see all the customization options, you should just go to the Matplotlib website and just search markers, line styles, and things like that. I will put the link to all the markers you can use for your plots in the description below, so you don't have to search it. But if you want to learn more about Matplotlib, just go to their website and look up the documentation. And we should also come with a label. Let's say sigmoid. And now let's see here. We compile the figure. And here we have the sigmoid function. The sigmoid function takes values from -1 to 1. So if we want to see it better, we should just modify our plot to show us a smaller range of values. And to do that, you just type plt.axis, and here you give it a list as a parameter. The first two values represent the x interval, so let's say -10, 10, and then the second values represent the y interval, so let's just give it 0 to 1. Sorry, I have said that the sigmoid function outputs values between -1 and 1, but I was wrong. It actually outputs values from 0 to 1. So let's run it, and as you can see, this is the sigmoid function. It is easier to see how it looks if you just modify the range of the values. So here it is. So now we are going to move on to the scatter plot. So like we did with the line chart, we have to import Matplotlib. So just go here, copy that, paste it, and let's continue. To make it more fun, we are going to create some random values for the scatter plot. So let's say data x equals data y equals. So these are going to be our two lists for our scatter plot. You'll see how a scatter plot looks in a minute. So to generate random values, we are going to need to import the random library. So here it is, and now let's just type x or random dot rand range. Our points will be in the range between 0 and 50, and we will have 50 points on our plot. So for x in a range 50, we will do the same thing for our y values. And now let's just build the scatter plot. To do that, you just type plt.scatter, and then you give it the two lists as arguments. So data x and data y. And to show it, just type plt.show. And just let's run our program. If we run our program again, as you can see, because the values are generated randomly, we have another scatter plot here. The scatter plot can also be customized. So let's just change the color of our points. Let's make them green. And to use another marker, just type marker and use another marker, for example a star. Now if we run it, we have some green stars here. Now of course we can also add a title to our scatter plot. scatter plot. So now as you can see, we have a title. We can also add some labels on the y-axis and on the x-axis. So plt.x label, let's say x values of our random points, and plt.y label y values of our random point. Another very cool thing you can do with scatter plots is that you can label each point separately. So let's try to do that. So in order to label our points, we will use a function called annotation. So let's see here. We will use a for x, y in zip data x, data y. For those who don't know, this zip function allows us to iterate through two lists at once. So x will iterate through data x and y will iterate through data y. If you still don't understand how this works, just Google it and try to understand it. Now let's use our function plt.annotate. Uh, Firstly, we will have to specify the label. Let's just label our points with a letter. Let's use the letter A here. Then the argument xy represents the point you want to label. So you have to give it a tuple with the coordinates of the point you want to label. That's why we are iterating through our list, because we want to label both, or not both, but all of our points. Now for xy text, you just give it some coordinates. These are relative coordinates of the text. So basically, these coordinates represent how do you want the label, the text, to be situated in report to, or to the point, basically. We'll see it in a minute. I don't know if I was able to explain it right, but I will try to explain it again when we actually run the program. And then you have to come up with another argument called text coords, and here you can give it two values: offset pixels or offset points. Basically, what this means is that you want to measure the distance from the point to the text in points and not in pixels. You can also type here pixels, and then you will measure the distance between the point itself and the text in pixels, but we will just use points. And now if we run it, let's see here, we have some problem. So plt.annotate label offset point. Now as you can see, it works, and all of our values are labeled as y. So this coordinate, the xy text, means uh, the coordinates of our text measured from each point itself. Now it is very boring to label off all of our points with the same letter. So let's write a function which generates a random letter. It is very easy to do that with the random library in Python. So let's just define the function random letter, and here we will define a string with all the letters in the alphabet. So letters equal A, B, C, D, E, F, G, H, Y, J, K, L, M, N, O, P, Q, R, T, U V X what R A B C. Sorry for that. I'm just trying to remember the letters and I'm just completely confused. R T K Q R S. Ah, that's the letter I forgot. T U V W X Y Z. Sorry, I was just confused for a moment here, but I really know the alphabet. Let's just move on. This is very embarrassing. Yeah, and now let's generate a number, or let's just return uh, a random letter from our string. So let's see here. Random dot rand range and the length of our letter string. And now we can just come here and instead of a we can use our function we have just built, random letter. Random letter. And now as you can see we have some random letters in our scatter plot. Another cool thing we can do with these plots, not only with scatter plots, is that we can save them. To save the scatter plots, just use the function savefig, give it a name, for example scatter.png, and you also have to specify the format, which should be png. And now let's run it, and here it is our image saved. So that's about it with the scatter plots. Now we are going to move on to the bar charts. So let's just copy our Matplotlib import line and let's paste it here. Now for the bar chart, we are going to give an example, or we are going to make a bar chart with the GPA of some random student. So let's come up with a list of students. Let's see here, students. Let's come up with some names. Anna, Bill, Justin. Let's see here, Mark, and Bob. And let's also give them some GPAs like 4, 3.8, 2.3, 3.9, and 1.6. I think there are enough GPAs. Now, to make a bar chart, you also have to specify the position of each bar. So let's just come up with let's just declare a list of positions and let's generate it. Let's say x for x in enumerate of student. So basically this function called enumerate returns us both the index of each student and each student in the list. So while the x will take value from 0 to the length of the student list, this underscore will take each the value of each element of the list, so like Anna, Bill, Justin, Mark, Bob, and so on. Now, because of the fact that the bar chart has a default length of 0.10, to make everything more prettier and to make the bar chart more in the center, we will add 0.1 to the position. And to make a bar chart, just use plt.bar. The first argument is the position, the list of position, and the second argument should be the GPA. So basically the height of each bar chart. And now let's just say plt.show and run it. As you can see, here is our bar chart, but of course we still have to add the names of the students to it. To do that, you just come here and type plt.xtick, and you also have to give it a positions, a list, and the list of strings you actually want to represent. And now, as you can see, we have the names of our students. You can also label the bar chart, so we can just use as we did with the scatter plot and the line chart. We can just use the functions xlabel to label the x-axis, for example, student name, and the y value, y label. Let's say here GPA scores, and let's give it a title. So bar chart. Of course, our bar chart can also be saved. To do that, you just use the save peak function and type the name of the file you want to save the data into and the format png. Let's run it again, and here it is. Here we have our bar chart. We can also save our line chart, so we will do that just now. plt.save pig line.png and the format png, and let's run it. And now we have our graph is saved here as a png image. Now, as I have said earlier, if you want to learn more about Matplotlib, you should just go to their website and follow their documentation. The link to their website and the documentation will be in the description below, so you can just click on that and go here. That was pretty much it about data visualization and Matplotlib. This is the end of this tutorial. I hope you have enjoyed it. I hope it was useful, and see you in the next episode of our series, of our data science learning series. Don't forget to like and subscribe, and see you soon. Bye!